What is this? That is not prime numbers. I know 49 is not a prime number. I know that 9 is not a prime number. Yet Llama thinks that this function actually finds prime numbers. Accuracy aside, you might want to run Llama on your system locally without all the restrictions that you're going to get with all these services popping up, possibly charging money, because you can actually take the Llama models, run it, and charge people for it if you want to. At least that's my understanding of the terms of service, unless you have over 700 million, unless you're Apple or Google, okay? How do we run Llama locally on an Apple Silicon machine? That's what I'm going to show you today. If you don't have an Apple Silicon machine, running Llama is easy. You go to the GitHub URL, and I'm going to leave all the links down below, including the instructions and the steps. You're going to go to this one, Facebook Research/Llama on GitHub. You're going to clone this repository, follow the instructions, and boom, you're done. That's if you're running on Linux or Windows, but this is not going to work on Apple Silicon. There is a C++ project that's also open source, and that one will. Now, you're going to need a few things for this. And again, I'm going to put all the steps down below. You will need to clone this repository, this Facebook Research Llama repository. So I've created a folder called LLaMA2, and I'm gonna git clone this repository. I'm gonna do this along with you, so you can do it along with me. There we go, clone. That's this one right here, Llama. Now, we're gonna go to this other repository, and this is the C++ port. This port is done by the same person that created Whisper, and I've done videos on Whisper and how to use that on the channel before. This one supports macOS, Linux, Windows, Docker. It supports all these models, Llama, Alpaca, and so on. There's mirrors for Python, Go, Node, Ruby, C#, Scala. The gotcha with this thing is that you need to convert your model from the original to a different model structure. And I'm gonna show you how to do that, don't worry. So let's clone this one too. Git clone, and boom, done. That's 2 out of the 3 tasks already done. Holy cow, what's the third task? Well, if you go back to the original repository, you're gonna need to scroll down a little bit, and there's a download section. And here, you're gonna need to click on this link that says request a new download link, and I will link to this link in the description also. When you go here, you're gonna need to fill in a little bit of information for Meta to keep track of you, accept the terms, and click on this accept and continue, at which point they will approve you, and a couple hours later, at least it was a couple hours for me, they sent me a link, and the link looks like this. This is the email I got from them. This link is not going to work anymore because it's only good for 24 hours. You just basically use this very special and very short-lived link, and that'll allow you to download all these models. How do you download the models? Well, this repository right here, the original one, will tell you how to do it. First of all, there's this download.sh file here. The email actually tells you the instructions. You visit the repository, you download it, and you run this download.sh script. When you run that script, it's going to ask you for this URL. Put that URL in, select which models you want. Here are all the models that are available. There's the 7B varieties, which are 7 billion parameter models, 13B varieties, and 70B variety. How big is all this stuff? Well, here's where I put all my models. It's in meta_models. I copied it into that folder, so I have the originals, and the total size of that folder is 354 gigabytes. Holy cow. So I created this folder called Meta Models, and I downloaded all the original models in there. Now, each folder has a checklist.chk file, and then a bunch of these PTH files. These are the actual models, but still all the other files are important, as well as the params.json. And when you do the download, you're also going to get the tokenizer checklist check file and the tokenizer model file. Make sure you copy those somewhere safe as well. So I put them here in my models folder. Now, once these download, and it took me a long time to download these, and I have fast internet, so maybe you want to start out with a 7 billion parameter model and just get your feet wet and then download the bigger ones later, which is what I'm going to show you right now. I'm going to use the 7B model. Let's go into that llama.cpp directory, and the CPP directory is that second repository I showed you, the C++ version. Now that we're here, we're going to build this C++ project. All you do is type in make in that directory. It's going to use Apple's Clang and build it, and it's going to build a bunch of binaries, but the 2 most important ones, the ones that we're going to use, let's do an ls here. It's going to be quantize and main. I'll show you how to use that momentarily. You're still dependent on Python because you're going to need to use a script in here called convert. This script right here is a Python script, and this Python script converts from the original models, from the source models, into this new format that this program runs on. So to run this Python file, we're going to need to install some Python dependencies. Now you might or you might not already have Python installed. I do. I have 3.9. This could work. I could just install the requirements. By the way, that's this file right here, requirements.txt, that contains all the requirements for the Python environment to have before you can run convert. All these steps, I know. I actually will add a little bit more steps for my environment, but you don't have to if you already have Python, a decent new version of Python installed. But what I like to do is I have a Conda environment, an Anaconda environment set up, and I'll create a brand new environment just for this task. And if you don't know what I'm talking about, I made a video on how to create and manage Conda environments. These are Python environments. These keep your Python projects separate so they don't interfere with each other with different version numbers and all that. I created that video and I'll link to that video down below if you don't know how to do that. So I'm going to do that real quick right now. Conda create, and I'm going to give this environment a name, LLaMA2. I'm going to activate the environment using this command, conda activate LLaMA2. And now I'm going to install the dependencies into this environment. Well, first of all, let's check the version of Python here. I have 2.7. That's not going to work. We need a newer version of Python. So I'm going to say conda install Python equals 3.11. And now inside this LLaMA2 environment, I'm going to have a new version of Python 3.11, just for this environment. If I check my Python version, 3.11. So now I can use this new version of Python to install the dependencies, which is this command, python-m pip install -r requirements. Boom, the requirements installed. Good to go. Now that our Python environment is set up and our Python requirements are installed, we can run this convert.py script. So I'm gonna paste it in here. I'm still in my Conda environment. Notice in the parentheses it says LLaMA2. That's the name of my environment. Python convert, and then I'm gonna give it the output file, which is in the models folder, 7b, and then the name of the model, outtype F16, and then where can I find the original model? Let's go through that real quick, shall we? I'm gonna open up my Finder here and we can take a look at where everything is. First of all, I'm inside my llama.cpp folder, right? Which is right here. Everything's inside my llama2 folder, including the llama.cpp. I'm running this convert script and I'm telling it that the output file should be in the models folder. Let's go on this side over here, give us more space. CPP, models. Well, there's nothing in that folder. We don't have a 7b directory in there, okay? So we need to create a new directory here called 7b. And this is for the $7 billion processed models. Did I say $7 billion? What am I thinking about here? I meant 7 billion parameter models. You can also create folders for the 13 billion parameter models and the 70 billion parameter models. We're just gonna do this with one, the 7 billion one. So that's gonna be the output file. It's gonna go into models 7b, and then it's gonna be called ggml-model-f16.bin. And where are we getting the original files from, the original models? Well, that's coming from llama2 meta models, llama2 7b chat. So this folder right here. Remember, these are the ones that I downloaded from Meta. It's gonna look into this folder and basically pick out the one it needs and process it. So let's run that. There it is. It's running it. Okay, so it's doing the conversion right now, this Python script that's included. And it converted this consolidated.00.pth into this one, ggml model f16 bin. It's just a different format. But now this file is huge. It's 13.48 gigabytes just for that model. And if you get to the 13 billion parameter model, it's 26. And the 70 billion parameter model is even bigger. It's what, 8 files that are 17.25 gigabytes each. That's huge. So there's another step, and that's to quantize these models into smaller file size. And we're gonna use the quantize command. Remember when we did make, we built main and we built quantize. Now we're gonna use quantize to convert this model that we've converted, to quantize this model that we've converted. Sorry, I didn't come up with this stuff, okay? I'm just a messenger, don't kill me. I'm gonna paste this command in here. Again, commands are down there. quantize models 7b. This is the one right here, the one we just converted. We're pointing to that, and we're gonna put the new one in the same folder, and this is gonna be the quantized version. So let's run that, and there it is, the q4_0.bin. And look how much smaller that is. That's 3.83 gigabytes now instead of 13.48. This is the file we're actually going to use to do our chat, to do our inference. Finally, it's time for the inference. To do that, we run main. Main is the program now. We can give it the model as the parameter, so -m, and we point it to this quantized model in the 7b folder. Then -n will allow us to specify the number of tokens to, I think it's the number of tokens. Correct me if I'm wrong. I think it's the number of tokens that we can respond with. I'm gonna set that to, I don't know, let's do 1024. It doesn't have to be. You can pick whatever number you want. Let's try this. I'm gonna run this, and it's spewing out all sorts of weird stuff. Yeah, I have no idea what all that stuff is, but it's doing it. There it is. That was generated by the 7 billion parameter model, and I have no idea what it is. If you run this again, it's gonna spew all sorts of things. Some of it is in German. Wow. Yeah, it even has some code in there, some Python code. So crazy stuff, crazy stuff. How do we get it to do something useful? If I open this up in VS Code, we can take a look at the code first of all, and you also have this little prompts folder here. Well, this has some examples. We can send one of these files to the model as an example or as a starting prompt. For example, this chat-with-bob.txt. There's a little bit of a primer and a little bit of a start of the dialogue, part of the prompt. And the understanding is that the model will continue or prompt the user to continue. Let's try this out. I'm gonna paste a new command here, and some of this will be familiar. Main, the model, and then there is something called repeat penalty 1.0. I have not looked into that. I don't know what that is, but it's on one of the examples in the repository. If you want to read through the repository, which you should probably do that, it might explain it. Then color-i, if you're using a terminal that supports colors, this will allow you to support multiple colors, one for user and one for the responses. And then you can send it the file, which is chat-with-bob.txt or one of the other ones in here. So I'm gonna go ahead and run that. Now this right now is running on the CPU. How do I know that? If I pop open Activity Monitor, you'll see that our CPU is being used here. I believe it's waiting for me to type something. Let's see. Hello. Bob says, how may I assist you today? Hey, it's working. And here is where I'm gonna hit it with my question. Paste. Can you write a JavaScript function to find prime numbers? Let's go. Of course, here is the JavaScript function that'll find prime numbers. This is a little bit different than the one it gave me earlier, but what the heck, let's try this out. Also notice that while that thing is generating, there was the main process name, and it was using a bunch of CPUs. You can actually specify, you can give the main program a flag, I believe it's --t for the number of threads to use, and you can use more threads and it'll output faster that way. Let's go to our JavaScript project here. It's a little node project I created to try this out, and looks like we pasted right in there without any modifications, and I'm gonna run it. Oh, prime is not defined. So it gave me a reference to a function that's completely not defined at all. Right, well, that did not work. So as far as reliability of the code that it generates, not exactly usable code. It's not like ChatGPT where you actually get usable code. If I go to ChatGPT and ask it that same question, well, let's see what it does. It's printing out the function isPrime, generate primes. It defined isPrime. Let's copy this code, paste it in here, save it, and run it. And find prime numbers is not defined. Well, it's because it's a different function name, so we need to change that. That's my fault. And there it is. Are these all primes? It looks to me like they're all primes. Yeah, primes to 100. So GPT is still kind of the leader in generating code. If you want to use Llama, do not use it for generating code or checking code or doing anything with code yet. And yes, I've tried this with a 13 billion parameter model and a 70 billion parameter model, and it's not consistent. And sometimes it gives simple answers that work, and sometimes it gives simple programs that don't work. Use it for creative tasks, use it for writing tasks, use it for completion of sentences, writing poetry. I don't think it's ready for code yet. So hopefully this was helpful to you. If you want to try this out on your own, make sure you check the steps and the links and the commands that I pasted down below in the description. Thanks for watching, and I'll see you next time.